Our topic today is permutation. Permutation is an arrangement of objects or items in order. But we shall start by looking at factorial notation, which is a tool that we are going to use in solving problems involving permutation. We now look at factorial notation. The symbol I with the dot underneath indicates factorial notation. This n factorial, this is now read n factorial, is the product of all whole numbers from n to 1. Thus, your n factorial here is equal to the number n into the number n minus 1 into the number n minus 2, number n minus 3, and so on and so forth. The ellipsis here down to 2 and finally to 1. This is in decreasing order. Thus, 0 factorial has been proved to be equal to 1. 1 factorial is also equal to 1. 2 factorial is 2 times 1 equal to 2. 3 factorial is equal to 3 times 2 times 1 equal to 6, and so on and so forth. We shall now take a look at some examples. Number 1. You have to simplify 12 factorial all over 9 factorial. Solution. Your 12 factorial all over 9 factorial is actually equal to your 12 times 12 minus 1 is 11 times 11 minus 1 is 10 times 10 minus 1 is 9. And we can actually have this one as 9 factorial. That it continues in this order. Everything here all over 9 factorial. Because of this 9 factorial, it will not cancel the 9 factorial and the denominator. This will result in 120 times 11. That will give you 0, 2, 11, 12, and 13. So this will give you 1,320. If you now divide 12 factorial by 9 factorial, and that will be the result of the division. We could actually solve this problem of 12 factorial over 9 factorial by expanding 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Everything here all over your 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. You will see now that you have actually spent a lot of time writing this out. You now also realize that the whole of this will also cancel the whole of this. In other words, instead of doing this expansion, we simply will write 12 times 11 times 10 and then times 9 factorial and then divided by 9 factorial. That is why this 9 factorial cancels this. This is the most simplified form of resolving this problem. It was this we now expanded, multiplied to give us our 1320. I would recommend that instead of doing this, you should be able to resolve or solve or simplify in this format. Example number 2, Find the value of 15 factorial all over 10 factorial times 5 factorial. Your solution, we have our 15 factorial all over 10 factorial times 5 factorial. This will be equal to expanding the numerator 15 times 14 times 13 times 12 times 11 and then times 10 factorial. Everything here all over 10 factorial, expanding 5 factorial, you have 5 times 4 times 3 times 2 and maybe just write 1. In most cases we do not need to write times 1 even though we know it's there because 1 dividing any number will not change it. Now you now discover that 10 factorial and 10 factorial will go. So we now have again 5 times, let's look at this now, we now have 3 times 2, 6, and we cancel this, and this is 2. So we now also have that your 4 will be cancelled by 2, and this 2 will also be cancelled by that. Now your 2 will cancel your 14 to give you 7. So everything in the denominator except 5 has been cancelled. So what happens? This becomes 15 times 7 times 13 and then times 11. All this all over 5. We now realize that 5 we cancel 5 to give you 1. 5 we cancel 15 to give you 3. So we can then multiply out to have 3 times 7 times 13 and multiply this by 11. You can use your calculator and then by calculator 3 times 7 times 13 times 11 equal to 3003, 3003. So you will have solved the problem also with the aid of the calculator. Example number 3, simplify n factorial all over n minus 2 factorial. The solution, you have n factorial all over n minus 2 factorial will be equal to n into n minus 1 into n minus 2 factorial all over your n minus 2 also factorial. So n minus 2 factorial and n minus 2 factorial will cancel, leaving it with n into n minus 1. You can leave it like that, or this is n squared minus n. This is also correct. Both are correct. Arrangements or permutation. The word arrangement and permutation are used interchangeably in this aspect. To arrange is to also permute. So permutation and arrangement are synonymous. In this wise, we have explained earlier that permutation is any arrangement of objects in a definite order. Let's take for example A, B, C. These 3 letters can be arranged as follows, taking any 2 letters at a time and without repeating any of the letters. So we can arrange our ABC taking any 2 letters as AB. We can also have it as BA. As AC, we can also have it as CA. As BC, we can also have it as CB. We have here 6 possible ways of arranging that. So we now say that the number of ways you can permute the letters A, B, C, taking 2 at a time without a repetition, will be equal to 6 ways. Now in this arrangement, our AB and BA are two different arrangements. Order is taken into consideration, into account in permutation. Take note of that, because we are going to meet another concept in which order is not taken into account. So permutation specifically, order is taken into serious account. Now, if there are P ways of carrying out an operation and Q ways of carrying out a second operation, then there are P times Q ways of doing both one after the other. I want us to have an understanding of this. Maybe you have 3 ways of arranging some objects, and you also have 2 ways of arranging another set of objects. Now, you will now have 3 times 2 ways of doing both one after the other. That is the point we are making in this case. So maybe you have your P ways of doing that is, you have P is equal to 3 ways, you have Q is equal to 2 ways. Therefore, to do both, which is P times Q, this is equal to 3 times 2 ways. And of course, that will be equal to 6 ways of doing both P and Q, carrying out the operations of P and the operations of Q. Now we go into the permutation of n distinct objects, taking R at a time. We're now trying to look at a formula that will be used in carrying out permutation. And this is denoted NPR and is defined as n permutation R equal to n factorial all over n minus R factorial. Or our n permutation R is equal to expanding it n into n minus 1, n minus 2 until you finally get to the last value. And this can be simplified to be n into n minus 1, n minus 2, and then until n minus R plus 1. So this format will be used in expressing n permutation R. Now let's take some example. 1. Simplify n permutation 3. Solution. Your n permutation 3 will be equal to n factorial all over n minus 3 factorial. Now this will be equal to n into n minus 1 into n minus 2 into n minus 3 factorial. And then of course this will be divided by your n minus 3 also factorial. Eventually this and this will go, leaving you with n into n minus 1 and into n minus 2. You can expand it, you can leave it at this point. That becomes the solution to that. That was the first one. The second one, you have n permutation 6, which is now equal to your n factorial all over n minus 6 also factorial. Of course, you can now expand as we did above to get the final result of these permutations. This eventually will give you n into n minus 1, n minus 2, n minus 3, n minus 4, and then n minus 5. Okay. And then we also have the third case where you now have n permutation n. This will give you the value as n factorial all over n minus n factorial, and this will lead you to n factorial all over 0 factorial. Remember we said earlier that 0 factorial is 1, so this is equal to n factorial over 1, and finally we have n factorial. So n permutation n is equal to n factorial. So that something like 5 permutation 5 is equal to 5 factorial. 3 permutation 3 is equal to 3 factorial, and so on and so forth. Example number 2. In how many ways can 5 different books be arranged in order? In how many ways can 5 different books be arranged in order? Our solution: the first book can be arranged in 5 different ways. Maybe the first book can take any of this position. The second book will not take any of the 4 positions, and so on and so forth. So this will be equal to number of ways will be equal to 5 factorial ways. And 5 factorial means 5 times 4 times 3 times 2 times 1. And the result will be equal to 20 times 6, which is equal to 120 ways. Example number 3. In how many ways can 7 different objects be arranged, taking 4 at a time? Solution: we have 7 different objects to be permitted, taking 4 at the same time. And that means 7 factorial over 7 minus 4 factorial, which will give you 7 factorial over 3 factorial. You already know what to do in this process, and the final answer will be equal to 840 ways. 840 ways. So that means 7 times 6 times 5 times 4. That is 7 times 6 times 5 times 4. And that is 42 times 20. And that is 840 ways, as said earlier. Example number 4. There are 3 different ways of going from X to Y, and 5 different ways of going from Y to Z. How many possible routes are there from X to Z via Y? Solution: the number of ways, number of possible ways is equal to 3 times 5, and that is equal to 15 ways. Let me give a little explanation. There are 3 different ways from going from X. Here is your X, and you have 3 routes to get to Y. And then Y, there are 5 routes to get to Z. So there are 5 routes. Let's say the routes 1, 2, 3, 4, 5. And they are now in location Z. It implies that if you take this route, you can go through here, you can go through here, you can go through here, and also go through here, or you go through this. Only this one will give you 5 routes. So we have 5 routes passing from here. This one will also give you 5 routes. This one will also give you 5 routes. So we have 5 plus 5 plus 5. It is in as 3 times 5, and that is equal to 15. And that is why the result was 15 ways. Example number 5. In how many ways can the first, second, and third prizes be awarded in a competition if there are 36 competitors? Solution: we have 36 competitors, out of which 3 will be selected. And so that means, remember, we go in descending order in 3 points. That is 36 times 35 times 34. Because it's 36 permutation 3. You know, by the time you subtract 3 from 36, you have 33. 33 factorial will continue from there, so they will cancel out. So no need to go into that process. You simply write 36 in descending order for 3 points. 1, 2, 3. So when you now multiply this out with your calculator, you are expected to have 42 840 ways of doing that. So you can now imagine the situation where selections are made for first, second, and third prizes when you go for these competitions. Number 6, how many 4-digit numbers can be formed using the digits 1, 2, 3, 4, 5 if no digit is repeated? Our solution, we are interested in any 4 digits that can be formed using those 5 digits. So we have 5 and then you perm 4. And so this will become 5 times 4 times 3 times 2 and then times 1. So all over 1. And the result is equal to 20 times 6 is equal to 20 times 6 is equal to 120 ways. I hope you understand the short form I've used here. Just like what I did in the example number 5. All I have said here is this is 5 factorial all over 5 minus 4, which will give you 1 factorial. And 1 factorial is 1. And then 5 factorial with 5 times 4 times 3 times 2 times 1. 1 will cancel 1 and you multiply this out and that is the result. Example number 7. How many 4 and 5 digit numbers can be formed using the digits 1, 2, 3, 4, 5 if repetition is not allowed? Please look at the semantics in this question. I don't want you to relate this to a situation where you can do or you can carry out an operation in S ways and carry out another operation in Y ways, and then the 2 operations can be carried out in S times Y ways. No. Look at this carefully. How many 4 and 5 digits? You cannot combine them together. So we have out of the 5 digits, we can permute 4, and this will give us 5 factorial, and that will be equal to 120. Then out of the 5 digits, we can also permute 5 digit number, so 5 permutation 5, which again will give you 5 factorial, and 5 factorial is also equal to 120. Therefore, the total number is 5 permutation 4 plus 5 permutation 5. And that is 120 plus 120 equal to 240 ways. Example number 8. In how many ways can 1 boy and 1 girl be selected from 10 boys and 8 girls? Solution. Here we are talking about selecting just 1 person from each group. So the number of ways of doing this, the number of ways of carrying out this operation is that out of the 10 boys, we choose 1. And then of course, out of the 8 girls, we choose 1. So this is like the example which I gave. S number of ways of carrying out an operation, and B number of ways of carrying out another operation. And carrying out those 2 operations will be the product. So that's what we have. And then 10 permutation 1 is 10. And 8 permutation 1 is also 8. And this is equal to 80 ways of selecting a boy and a girl. Example number 9. How many 3-digit numbers can be formed using the digits 1, 2, 3 if any digit can be used more than once? Solution. Let me explain this. There is a formula for calculating the number of ways of carrying out an operation if the repetition is allowed. So we have that the number of ways, okay, of permuting n objects taking R at a time if repetition is allowed is n raised to power R, where n is the number and R is the number of times, is the number of times, yes. Objects taking R is the number that are taken, is the number taken at a time. So in other words, for this case, therefore, our n in this case, there are three numbers involved, 1, 2, and 3. Not because there's 3 there, please take note of that. Not because there's a 3 here, there are 3 numbers, 3 digits. So, and then we are told if any digit can be used more than once. How many 3-digit numbers? And we are taking 3 digits. So, our R is equal to 3 because we are taking 3 digits. The 3 digits will be taken at the same time. Therefore, our n raised to power R is equal to 3 raised to power 3, and then it is 27 ways. Let us now look at arrangements including identical objects. In this case, we are looking at a situation where you have identical objects or indistinguishable objects or items. You can have a word as statistics, and you discover that S appears in statistics more than once. How do you distinguish one S from the other if they are of the same color? So in this case, the S, they are said to be identical. They are indistinguishable. In other words, for us to be able to permute or to know the number of ways that such items can be arranged, taking all at the same time, we will now use the formula below. That is, we are saying that this is a permutation involving some identical objects. The number of arrangements of n objects taking n at a time, in which n1, n2 to nk objects are alike, is given by n factorial all over n1 factorial times n2 factorial dot dot dot, this ellipsis, times nk factorial. This dot 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 means continues in that order. So this is the formula you will use to permute the number of ways that such object can be arranged. Example number 10. How many arrangements are there using the letters of the word statistics? Solution. The word statistics contains how many letters, irrespective of any letter being repeated? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 letters there, whether repeated or not. In this word statistics, our S is 3, our T is 3, our I is repeated twice. Therefore, the number of arrangements will be equal to 10 factorial all over 3 factorial, 3 factorial, and 2 factorial. And then we simplify this as best as we can, and then your result will be equal to, if you are able to do this, you will have 5040 ways of arranging these word statistics. Those of us who play scramble sometimes, you know what we're talking about. You can have 7 types of different letters and you arrange them to form a word. How many different arrangements can you have depending on the types you have? So that's the idea of arrangement in this case. Example number 11. How many different numbers of 7 digits can be made using the digits 3, 3, 3, 5, 5, 5, 5? Solution. How many digits are here? We have 3, 3, 3, 5, 5, 5, 5, equal to 7 digits. Repeated or not? Then now, we are told to find the number of digits that can be made using the how many different numbers of 7 digits can be made. So taking all the 7 digits, so this will be equal to 7 factorial, 3 digits repeated, 3 is repeated 3 times, so 3 factorial, 5 is repeated 4 times, and then that is 4 factorial. So you will simplify this. Let's do this for you now. Times 5 times 4 factorial all over 3 factorial and 4 factorial. 4 factorial will cancel 4 factorial, and then we have 7 times 6 times 5. 3 factorial is 3 times 2. This is 6, we cancel that. And 7 times 5 will give you 35. That's the solution. Conditional permutations. By this, it implies that a condition is attached to the arrangement you are asked to make. For example, find the number of ways in which the letters of the word school can be arranged. 1. If the 2 O's must be next to each other. 2. If the 2 O's must not be together. Now, let's take a solution. Here is the word school. For the 2 O's to be together, let's close them up in this form. So, we have S, C, H, and L. If we remove the 2 O's bunched together, we want to fill them in between these letters. We can put it here, 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 we can also put it at the end. So we have 5 ways of doing that. So we have 5 ways of fixing these 2 O's. After that, you have the SCHLE can be arranged in how many ways? In 4 factorial ways, bringing the total number of ways of doing that. So therefore, our 1, we have that for the 2 O's to be next to each other, we have the number of ways will now be equal to the 5 times 4 factorial. Technically, this means 5 factorial, because if you expand this, 5 times 4 times 3 times 2, which is 5 factorial. And 5 factorial is equal to 120 ways. So for it to be together, this can be arranged in 120 different ways. The second aspect, if the 2 O's must not be together, our solution, if the 2 O's must not be together, so we have our school, and these 2 O's must not be together. So let us take it out. We are left with SCHL. And then this can be permuted or arranged in 4 factorial ways. When we have done that, we will take the first O. So the first O we occupy how many positions you can occupy? Let's see, S, C, H, and L. The first O can occupy here, you can occupy here, can occupy here, can occupy here, can occupy there. This is equal to 5 places. Then the second O we occupy the remaining 4 spaces, because one O has taken the 1 position out of the 5. So the remaining one, the second O can take any of that position. So at the end, you must know that the total number will be 4 factorial times 5 times 4. But you will recall that the 2 O's can be interchanged. The 2 O's can be interchanged, or they are indistinguishable. But the two O's are indistinguishable, or rather, let's just say they are identical. They are identical. Therefore, the total number of ways will be equal to 4 factorial times 5 times 4 divided by 2. And so when we solve this, you will have 240 ways. You can simplify this. 4 factorial means 24. 24 times 10 is equal to 240, because 2 we cancel 4, that is 2. 10 times 24 is 240. So that would be the number of ways of permuting this word school if the 2 O's must not be together. Permutation in a ring, or cyclic permutation. Under this concept, permutation of objects in a circle is called cyclic permutation. The number of cyclic permutations of n distinct objects, taking n objects at a time, is n minus 1 factorial ways. What we mean by this is that in a circular form, like a circular table, rank conference table, of course, if you have to find out the number of ways of arranging a committee member that you want to use the table for a meeting, one of the seats will be fixed and the other people will be arranged around that seat. Usually maybe the chairman's seat is already fixed. The others can take any of the seats that's available. That's why you have to subtract 1 from the number of members of that committee, and the rest will sit round the chairman's seat. So that is why we have n minus 1 factorial ways of doing that. Take note of this. In a circular form, 1 position, 1 seat must be fixed, and the others are permuted or arranged around that. If the objects are arranged on a ring which can be turned over, the number of arrangements will be n minus 1 factorial divided by 2. Again, 1 position is fixed, but this time around we are dividing the result by 2, because if the ring is facing up, that is 1 arrangement, and when you turn it over, that is another arrangement. So we have to divide it by 2 to know the number of arrangements that is possible. Example number 13. Number figure 1. In how many ways can 5 people sit at a round table? Number figure 2. If 2 people must sit next to each other, in how many ways can this be done? Number figure 3. If the 2 people must not sit together, in how many ways can the people be seated? Our solution. 1. Here is a situation where we have 5 people sitting at a round table. And of course, one position will be fixed. So the number of ways of doing this will be n minus 1 factorial. And of course, our n is 5 minus 1 factorial. And that is equal to 4 factorial. 4 factorial is equal to 24. So the number of ways of arranging or sitting 5 people at a round table will be equal to 24 ways. Number 2, if 2 people must sit next to each other, in how many ways can this be done? First of all, the 2 people will not be fixed. So the 2 people are fixed. And then, of course, but these 2 people can be arranged in 2 different ways. They can be arranged in 2 factorial ways. Then the remaining 3 people, so the rest 3, can be seated in 3 factorial ways. In other words, the total number of ways this can be done will be equal to 2 factorial times 3 factorial, which is equal to 2 times 6, and that's equal to 12 ways. So the number of ways that this can be done will be multiplying 2 factorial by 3 factorial. Number 3, if the 2 people must not sit together, in how many ways can the people be seated? Let us practicalize this. First of all, let one of them be fixed. So let's fix this one here. Then let's keep the other person because they must not sit next to each other. So the other 3 people, one can be here, one can be here, one can be there. Then what happens next? So it means that these 3 people can be arranged in 3 factorial ways. So the 3 can be arranged or can be seated in 3 factorial ways. Now that that is done, you now discover that because the other person will not sit next to the first one, he has the option of sitting between this and this, which is the arrowhead here, or between this person and this person. So he actually has 2 possible ways of doing that. So we now have, in this regard, that the other person has 2 ways of taking this position of sitting. 2 ways of sitting. So, as indicated by the arrows. So how many ways do we have? The number of ways will now be equal to the 2 times the 3 factorial ways. 2 times 6 equal to 12. So you have 12 ways of doing that. As a matter of fact, all we need to do is to subtract Roman figure 2 from Roman figure 1. The solution in 2 should be subtracted from the solution in 1. That is 24 minus 12 to give us the same answer as 12. In other words, we have 1 minus 2, which is equal to 24 minus 12, and that is equal to 12 ways. This is the short form, if you recognize it, that you can use to solve the problem and you have it accurately as well.